Good morning, good afternoon, or good evening to everyone who've taken the time to join this webinar. Thank you for your time. So let's get started. The title for today's webinar is How to Benefit from Common Platforms that Support IT and OT Convergence. So let me introduce myself. So my name is Vishal Prakash. I'm a product manager with Prosoft. I've been with Prosoft for about 18 months now. My background is in SCADA and telemetry, specifically in the RTU world. Um, and for people with questions, please feel free to use the chat window to put in your questions, and then we'll get through those questions towards the very end of this presentation. Let's get started. So for those of you who don't know, Prosoft has been around for over 30 years and is typically known as the Modbus guys. Um, that's because our bread and butter is we do protocols and we're really good at them. We've got a number of in-chassis and gateway type solutions that convert from legacy protocols through to new modern ones, including TNP3 and OPC UA. But we are much more than just Modbus guys. That's how we started. Um, Today, Prosoft is really the connectivity experts. What we're really good at is to provide connectivity, different types, whether it's wireless, whether it's wired, whether it's cellular. Wireless includes radios or industrial Wi-Fi. But what we do is provide this connectivity to industrial control systems and then ensure that the data, so this is the industrial protocol data, is transferred from A to B safely and securely, which with those two is really the first step of our IIoT. If you don't have that good connectivity and you don't have the data, you're not really going to establish or complete your IIoT type exercise or solution. Um, Prosoft focuses on those 4 applications listed on your right-hand side. They do cover a wide area of vertical markets. So the agenda for today, we're going to look at some definitions. We're going to look at how IIoT works at a very, very high level. We're going to understand why it's gaining steam, what's data logging, open protocols, and then how to actually converge your machine price data. And then we should have time for Q&A at the end. Okay, so for us to effectively answer, which was the title of this webinar, which is how to benefit from common platforms that support IT and OT convergence, we have to do some learning and we want to understand some of the common terminology. So let's start with this. And the first one is, what is a common platform? A common platform is based on some open standards, but it's not necessarily open source. For example, like Linux is open source, but a platform is based on a bunch of open standards. It does include API or application programming interface, which allows for third-party interface. So basically allows you to request or to transfer data between 2 different types of platforms. So as an example, Prosoft has got a data logger module that's got REST API support. And what that allows is for a third-party program, so this could be like, for example, a Rockwell historian, could be OSI Pi, could be any type of other SCADA systems or SQL database. It would allow those programs to use JSON encoded messages, and it's just one type, to talk to the data logger module and request data. And when the module receives that message, it will know how to respond to that with the right type of data, and that could be a tag name, it could be some diagnostic information, it could actually be the actual timestamp record that it's looking for. So that would be one example of a common platform where you've got 2 completely disparate systems, like SQL that's talking to an industrial data logger requesting data that it understands. The next definition we want to look at is, what does IT and OT convergence mean? And I understand there's a buzzword, there's a lot of this going on. I wanted to break it down, and at a very, very high level, what this convergence means is the integration of information technology, which is your IT data, and operational technology data, OT, that will help drive productivity and efficiency. Ultimately, when you want to do something, you want to see what the benefit is. In this case, it's to drive productivity and efficiency in your process, in your plant, and so forth. Um, some examples of IT data includes infrastructure data, actual process information and commercial information or commercial data, and then your OT really, and again, I'm pretty sure most of us in this call would already know what SCADA is. So this is typically your SCADA and control system type data. So an example here, if you look at a solar power generation plant, their OT data would be what their current production capacity is, what equipment is operational, the efficiency of those solar panels at any given time. And then if you look at the IT data, that would be more like, what is the current price, market price, what's the demand information. So does the local authority need, how much power do they need? Can they sell it to somebody else? That would be sort of coming in from an IT perspective into that. What you're really looking for in this convergence is sort of a common source platform to provide both of those pieces of information to the key decision makers who now have that information in real time to make the appropriate decisions. So for example, do they sell power to company A or to company B? Do they store it based on the price? So all of those decisions now, rather than looking at charts and looking at, waiting 3 hours for the printed information to come, you now have this real-time access to that critical information that helps a business make better decisions. If you look at those two things, they lead to this next definition, which is the Industrial Internet of Things. Industrial Internet of Things, or IIoT, was really a term developed by GE, and it is an evolution of the DCS SCADA. So, in DCS, obviously subsets of that into PLCs, RTUs, but a very common term that's used is ICS, or Industrial Control System. So it refers to that interconnected field of devices in industrial applications. Previously, it was coming into a server, which was a SCADA, but now it is taking that information and the connection of all of those devices to the cloud that can facilitate data collection, exchange, and the analysis, again, with the aim of improving the efficiency and productivity, which, if you're going to do those things, should lead to increased profitability for the business. There's a bunch of definitions out there. Wikipedia is actually a good source, believe it or not, but there's lots and lots of information articles out there. So if you look on the web, you will have no shortage of information at all. At a very high level, I want to look at how does IIoT work. And there are three main components to this. The first one is the client. So this is things like device sensors, actually in the field, PLCs, RTUs, gateways. Typically, they would support some kind of an IIoT protocol. One of the more common ones is MQTT, which stands for Message Queuing Telemetry Transport. It's a very lightweight and open protocol. It's very simple to implement. And the key word there is that it's an open protocol. We're going to talk about open protocols a little bit further in this presentation or in this webinar. So you have this client, like all of those devices, and what they will do is they collect the information, they would connect, and they would publish, or basically push technology, where they're pushing that information to what's called as a broker. So the broker is responsible for receiving those messages from the clients, filtering them, and then having them, it can either send it to the subscriber, or it can store it there where the subscriber can go and request for that information. And that broker can be a PLC, it can be an RTU. You've got a lot of open source, these common platforms that we mentioned, type brokers. One example is Mosquito, but there's lots of them out there. And then the third part of IIoT is the actual subscriber that wants to view this information. And typically they would subscribe to the broker to say, give me this piece of information. Again, if you look at this from a traditional sense, people who've been, who know SCADA, who know PLCs, it's very, very similar. The difference here is that typically with SCADA, you generate the reports, you'd send it out, you'd have access. Whereas here with the subscriber model, it is more I want A, B, and C type information to help me do my job better or to help me make this decision. I don't need access to everything. So that's the key difference here between what IIoT does and what sort of the traditional SCADA did. So why is IIoT gaining steam? It's no longer a buzzword. It's actually a reality. There is a lot happening, not just in the consumer world, but also in the industrial world as well. So according to one of the research companies out there, the expectation is for over 21 billion devices to be connected by the year 2025. And 2025 is not that far ahead. So why this massive expansion? Why so many devices are being connected? One of the driving forces for this is because of this, the ubiquitous cellular coverage. I was listening to a TED Talk some time ago now where the gentleman was saying that the second most abundant thing available on Earth today, other than the air we breathe, is cellular coverage, which is pretty astonishing. So not only have we got sort of this universal coverage that's getting better, more reliable, more efficient, but also the pace at which this technology is changing uh, to ensure that reliability and that the coverage is getting better and better. Again, with new technology and stuff, we're going from 4G to 5G, and if you can actually see, there is already significant areas where 5G is being trialed and tested and so forth. And 5G promises a whole bunch of other benefits um, for specifically around the IIoT application space. Okay, the next one I want to look at is data logging. And again, data logging is nothing new, right? So who remembers these old chart recorders? Or even the manual recording. I've seen instances where people, the only record that they have is having gentlemen drive around in trucks and write down the readings on a piece of paper that they come back and then they enter it either into a book or their modern version is into an Excel spreadsheet. So data logging has been around, for a very, very long time. What is it? It basically is a record of a variable with a date and a timestamp at the source. The variable itself, it can be any type of variable. The date and timestamp is typically in Greenwich time format with millisecond resolution, and the source is when the information is coming into the control system. If you've got a high capacity, a dedicated data logger has got a number of benefits, and that includes high capacity storage, which then means that you're not going to have any holes in your data. It also means you can do high frequency logging, which is required for certain types of applications. Having a dedicated logger allows you to talk to multiple devices, which means that you can have sort of a single product that talks to different types of control systems, brings all the data where it needs that support for that multi-protocols for the downstream. So you could have a PLC that talks Ethernet IP, another PLC that talks DNP3, but you could have a single gateway, a data logger that would go and communicate to both to bring the data in, and then you would have one data format for upstream communications. One of the things I mentioned here is the no holes in data. That's very important. And the only way you can do that is when you have total local data logging, because that means that even if your communications goes down for whatever reason, you still have this logging functionality. So for example, like I say, no holes in your data, you could be trending temperature, pressure, level, whatever it is. And let's say if you're doing something like an electronic logging where you're logging at the SCADA system or at the front end on a server, if you lose communications, you don't have data. Then when the system recovers, it would reconnect. But what you would really see is that flat line in that period where you've lost communications and you don't have an accurate representation what happened during that time for that process or at that remote location or whatever it is. But by having that local data logging, the fact that the data log is continuing to log even though there's no communications, it means that you're going to have a more accurate picture either of the process, the variable that you're logging, which should tell you what exactly is happening on site. And this is now a requirement for certain types of applications in some vertical markets like water and wastewater. So this data log is really critical. And if you think about what IIoT is all about having that data, having more data from all of these additional devices that will then help you make those better decisions. So this data logging is sort of a critical part of an IIoT application. The next one we're looking at is open industrial communication protocols. And again, this is an important part of that IIoT and the convergence that we're talking about. Some of the early protocols, industrial protocols, are very proprietary. They were purpose-built. They were not very flexible. It did its job, and it did its job really well, but they were not very flexible beyond the application that it was designed for. It did lock in a customer and was not really very expandable. So, if a customer wanted, say, is not happy with the service or wanted to try something else, the costs were pretty significant to change. And they were very application specific. Modbus really started this trend in open standard protocols around the 70s. Today, even though Modbus is an open standard, you actually have many, many variations. You have things like Enron Modbus and so forth. But they are very well suited for legacy pole-only type systems. And it is actually quite an efficient protocol. Today, some of the more open industrial communication protocols out there, you've got IEC 60870-5-101 and 104, which came out of Europe. And then sort of North America's equivalent to that was DNP3, or Distributed Network Protocol, developed around late 80s, primarily used in the electrical industry. And it's got a bunch of advantages. One of the big things is the time stamping, again, to ensure no holes in the data, and then you've got access to all of the diagnostic information as well. A newer one to join that group is IEC 61850, again, primarily used in the electrical world, but it's finding its way to oil and gas and other applications. I mentioned MQTT previously. AGA stands for American Gas Association, and that's a set of standards to do gas flow calculations. It still is a protocol to communicate. You've got OPC, HART for field instruments, and then Ethernet IP. Again, there's more, but this is a list of some of the more open protocols out there compared to when communication started in the industrial world, sort of around the 50s, 60s kind of thing. So why are open protocols important? The interoperability between various hardware platforms, and that's a huge customer benefit. If you think about it, a customer could have 10 different hardware types as part of their system, but they could all talk one common language, either for communications between them or for communications back to the top end. And that ensures that they don't have to have 10 different top ends in terms of trying to manage this entire thing. The common data structure in some of these open protocols, it allows for a lot of diagnostic information to come through rather than just status or value information, which was what Modbus did. Modbus basically told you whether digital was on or off. Analog, you got a value. It didn't really provide a lot of diagnostics. Whereas you look at protocols like 61850 or DNP3, they can tell you things like, was the digital input locally forced? Is the hardware platform that input is connected to, is that working? So you've got all this additional diagnostic information that is very, very useful. And many of these open protocols have support for both push and pull technology. So push is report by exception, where the device can initiate the message to send data to a top end. And again, that's a critical part of IIoT. Or you've got the pull, which is sort of a background check, health check to say, is the device working kind of stuff. Now, open protocols have been used in OT for quite some time now. I said, you got Modbus, you got DNP3. So these are some of the open protocols that have been used for quite some time. Open protocols are also common or getting popular in IT as well. and you got things like SNMP and MQTT and JSON. Um, and today you've got industrial control systems that have got support for these IT type protocols as well. So if you've got SNMP support, for example, um, now in a SCADA system, not only can you get RTU information, but you can also go and get, how is your switch performing there? How is your router performing? And you can have that data integrated today. So let's just do a recap of what we've learned so far. We're going to have plenty of time for Q&A. We've looked at the definitions of what IT and OT convergence means, what is a common source platform in IIoT. We've looked at how does IIoT work and why it's gaining steam. Why is there so much emphasis on it? Why are so many people sort of jumping on this no longer a bandwagon, but really understanding and really realizing what the benefits are and saying, okay, I could use this in my application or process. And then we looked at data logging and protocols. So what I want to do now is to look at how to go about implementing this IT-OT convergence, that'll benefit your organization, which really is what this webinar was about. Okay. Really the first step in this process, you've got to define the problem. What is that? And to define the problem, some of the steps that you need to take or some of the things that needs to get done is what is the current status of what you have, both your IT and your OT systems. And you need a very thorough analysis of what's present, what the function of each piece of device is, the purpose, and how does it operate today. And this is a fairly significant and a fundamental task. You also want to make sure that when you're doing this, that you have the right person doing it. It's somebody that's really got a knowledge or an understanding of both what OT and IT is. They don't necessarily have to be an expert in both, but they've got to understand, have a good understanding of what OT is and what IT is, and understand some of the benefits and why they're doing this. We've got a new name for some of this. It's called an ADX type engineer or an automation and data exchange engineer. But fundamentally, it's somebody who really understands both of these systems, processes, like I said, a little bit more than a basic understanding, but not necessarily an expert. Then the next step is you really want to sit down and as part of your definition of the problem, you want to state, what are the issues that you want to solve? For example, on everybody's mind is it cost reduction. And then if that's your thing, how do you achieve it? Is it through newer technology? Is it better productivity? Is it better supply chain integration? Do you need more real-time information to make better decisions? So you got sort of all of these different things. You want to really look at what issues you want to solve. Once you've defined that, then you want to go and see and do some research on have these issues been solved previously and how they were solved. So there's no point reinventing the wheel. And again, one of the first things that I said was this common platform or this common source. There are so many tools out there today that you can readily use. You don't, step one should not always be, is how do I invent this in-house? How do I make this in-house? I totally get it as an engineer. There's a lot of pride in doing that. But is that the best business decision? Is that where the dollars are best spent? And if you look at today's solutions out there, they do solve a number of problems. You also really need to define why these issues need to be solved, to make sure that it's not a science project, that they're real business issues, and then there are real benefits in solving these problems. So once you've defined the problem and you've understood this, the next step is to look at the challenges. And you've got two main types of challenges. So you've got a technical challenge and you've got business challenges. As part of the technical challenges, and we really haven't mentioned this word in this webinar previously, which is security. One of the things, the technical challenge when you look at a solution or when you're looking at trying to solve a problem is you want to make sure that whatever you're looking at is both OT friendly and IT secure. And I'm going to expand on that in the next slide, which is why it's bolded. Some of the other technical things that you want to look at and make sure that you understand is adaptability and compliance. Do you have the skill set? Do you have the human power to solve this problem? Do you need to go and get outside help? Any environmental issues? If you look at the business side of things, obviously the more common one, obvious one is the cost versus benefit, so your return on investment. The risk analysis, that includes risk of not doing anything versus doing something later. You want to look at that entire time period and stuff. And the other one is this IT-OT culture clash. And again, I'm pretty sure that most of you on this call would understand some of it, live it every day. Again, depending on where you sit, it could be one or the other. And that's the other advantage of this new type of engineer that I mentioned, the ADX, or the Automation and Data Exchange Engineer. So if you've got somebody that really understands both, they could act as the break or the person in between, the go-to person for both of these teams to ensure that your project is executed smoothly. So, you define the problem, you've got the challenges figured out, you've written them. So how do you now finally solve? Sorry, before I go to that, let me expand on the OT friendly and IT secure. So what I think, what it should be in terms of OT friendly, some of the key points that OT needs to look at, and then security from an IT perspective, what they need to look at are these main points. OT, you want something that's easy to configure and set up. You want something that's easy to configure between the various sites, assets. You want a separation of the data on the control plane, and this is something that's important because, again, when you're doing IT, you're bringing all this data in. What you want to ensure is the communications is separated from things like, for example, device management. So if you've got a gateway out there, you're trying to connect to the gateway to check its status. You don't want that to affect the communications, the function of the gateway, which might be is to provide connectivity or to ensure that data is being sent from A to B. That critical function, you don't want that to be interrupted with, as a maintenance function, you may be, let's say, connecting to the gateway, to check its status, to make sure there are no errors and so forth. Having no software to install, I think, is something that's very important. A cloud-native solution ensures, easy maintenance, high security, because now you don't have another piece of software that needs to be maintained. And if you look at sort of the concurring IT side, anytime there's a piece of software involved, IT needs to keep it up to date, make sure all of the patches are applied, and not just on one PC, but across all of the machines in the organization. Whereas if you look at something that's cloud native, typically the reason it's cloud native is there's one place, it's in the cloud, and every time you connect, you're always connecting to the latest, greatest, and most secure. You want to have more bandwidth and speed. IIoT is all about data monitoring more assets, which means if you don't have the bandwidth and the speed, then there's no point simply adding all of the assets that you want to monitor in and then completely slowing your system down. You want support for lots of protocols, and again, especially if it's sort of an organization that's got a bunch of different ICSs over a period of time, then having that support for multiple protocols is important. Which leads into the next one, which is the open source to support disparate systems. Remote access is a critical part of IIoT. You want to be able to remotely access or remotely connect to the system easily and securely. It goes without saying the high availability and reliability, and then diagnostics. And again, as these systems get more complex, the more information you have that helps you diagnose the problem, the better it is. Security, if you really look at the first few points, what that relates to is something called as defense in depth. Defense in depth basically means that security is not a one-stop shop. It compromises of several levels where you look at everything from the device through to the network, through to the data transfer, the connection, and then the actual process itself. And you can do all kinds of things in that framework, in that defense in depth framework, many of those comprise that list that I've listed up there. Okay, so let's look at the solution. So your solution should really be led by someone that has got that IIoT knowledge. Again, I go back to that engineer that I mentioned, an automation data exchange type engineer that's really understanding both processes. Don't have to be an expert, but they need to have a good understanding so they can really make sure that the solution, and the idea here is you're trying to converge IT and OT, and if you've got somebody that does not understand one or the other, you're not really going to get what you're paying for or what the aim is going to be. The solution should include time to learn and evaluate what existing solutions are out there. Having a realistic plan is important. Again, trying to do everything at once is not realistic. You want to make sure that there's lots of intermediate goals that can provide measurable and demonstrable results, not just to yourself as somebody who's executing the project, but also to the management and the team as well, so they can see the benefits of converging both the IT and OT data. That again, ultimately the aim is to ensure that the efficiency and the productivity for the business is bettered, which should then lead to a superior bottom dollar, increased profits. Like I said, we should have plenty of time for questions. Let me open the floor up for questions. We have a question from Mr. Bob Al-Hindi, and that is this presentation available? So a recording of this will be made available to all of the attendees, and we can make a copy of the presentation available as part of that as well. There's a question from Mr. Newton Fernandez. The question is, can Prosoft's IoT gateways work with any MQTT broker? The answer to that is right now, gateways, so we've got, for example, an OPC UA gateway. The MQTT itself is being done in what's called as the LDM module. So once that's implemented, yes, that should work with any MQTT broker. We've got another question from one of the attendees, which is, what do you think the ADX role will look like in the future? Like I said, I think the function of the ADX engineer, if we get to that, is somebody as a person who has got a good knowledge of both IT and OT processes. The principles are basic fundamental principles of operating in both of those roles, or within the business environment, and sort of taking that knowledge and as business and industries move towards this concept of converging and using data from different aspects of the business to ensure the increase in productivity and efficiency, this person is going to become more of a key to ensure they can manage that and act as that go-to person that can translate both of these things and provide the required information. Really good question from Newton Fernandez again, which says, this IT-OT integration is mostly being guided by IT team or OT team? That's a great question. I think it really depends. I really think that this is being driven from a higher level, because once the business understands what the business benefits are, you'd have somebody at a high level driving the decision to go down this path. But once that's made in terms of which team would actually handle the integration, that really depends, I guess, on the organization, who's got the skill set and so forth. But yeah, that would be very dependent on the organization. But I think the decision itself to move forward with this convergence would be a business decision higher than just at the operations of the IT or OT. Thank you. This one is from Shannon Landry. Does Prosoft intend to roll out MQTT with no standard, or will there be an option to use Spark Plug or other types of industrial systems specific standard? Shannon, that's a great question. I don't have the answer for you today, but the intention with the MQTT is to make sure that it's compatible with as many systems out there. And again, I spoke about the common source, the open platforms, but that is a very good question. We're aware of Sparkplug, but I'll need to get back with my development team before I can provide you with a more accurate answer. Okay, so if there are no other questions, we've reached the conclusion of this webinar. So thank you again for taking the time to sit through this. Hopefully it's been useful and educational. If you've got any questions, feel free to please get in touch with us or your local Prosoft representative, and we can certainly help you with what we've discussed today. Thank you again.